Okay, so we have some questions on some problems here before the exam. So let's go ahead and look at some here. So this first problem is, I'm going to just kind of abbreviate it. Can't remember precisely what, here, like, just a second, I can get it here in a second. This is section 4.4, number 13. And so basically, with this problem, we have a box with a square base. And the volume is equal to 16 cubic feet. And then it's talking about a bunch of costs here. It says that the bottom of the box costs twice as much per square foot as the sides do, and the top costs half as much as the sides do. And then we're supposed to find dimensions for cheapest box. Okay, well, it's not really necessary to have a picture for this, but I'm going to go ahead and draw just a picture here. Let's see how I do here drawing. So we've got a box, square base, it's not great here, but it's good enough. Square base, and then it's got some height here. So I'm going to label a couple things here. First off, I'm going to label the box bottom here as sides x and x, and then I'm going to label the height of the box as y. So right away we know that just volume is be x squared times y is equal to 16. Okay, now we're trying to minimize cost, and the cost here, it looks like we're not given enough information, because really if you think about the cost would be equal to the price per square foot times the square footage. But we're not given the price. But this is where we can just make life easy, and we can just say, well, we're just going to assume that the price is just 1. How can I assume that? Because they've given me information for being twice as much and everything else, and basically what you could do, well actually I'll show you here what you can do here. So if you say cost is equal to price times the side plus 2 times the price for the bottom plus 1/2 times the price for the top. Well, what you can do here is you can look and you can see, hey, I could factor a p out, and so you'd have side plus 2 times the bottom, or sides I should say, plus 2 times the bottom plus the top. So you could just divide by the price then, and you'd have cost per price, but the point is you can since you can factor that price out, we can just simply ignore it. Alright, so let's get in here. Well, let's first off look at the sides. We need to figure out the area for the sides. And the area for the sides, well, they're just x times y, and we have 4 sides. And then the bottom, of course, is just x squared, and the top is also just x squared. So if we want to think about the cost here, we have cost is equal to, I have 4 sides, so 4 times xy, plus my bottom, but my bottom costs twice as much as my sides do, plus the top, but remember the top costs half as much as my sides do. So then my cost is simply 4xy plus 5/2 x squared. Now we still need to get this with one equation, one unknown, and so that's where we of course use the volume expression here, where we have that, what was it, 16 is equal to x squared y, and since I've got 16 is equal to x squared y, we would get, solving that probably for y makes the most sense, 16 over x squared equals y, and then we substitute that into the equation, and we get 4 times 16 over x squared times x plus 5/2 x squared, 64 over x plus 5/2 x squared. Now we're ready to take a derivative and find critical numbers. So if I take a derivative of this, we'd get negative 64 over x squared plus 5x. And then we solve this when it's equal to 0. And if we do that, we'd get 64 over x squared equals 5x. 64 over 5 is equal to x cubed. And then we would get x cubed, or x, I'm sorry, and you get 2.34 feet. Now we have to make sure that I found a maximum here, or sorry, not a maximum, we're minimizing cost, so I need to make sure I found a minimum. And you can use the first derivative test or the second derivative test. I'm going to use the second derivative test. So my first derivative was negative 64 x to the negative 2 plus 5x. So my second derivative is simply 128 x to the negative 3 plus 5. And then doing the second derivative at 2.34, you'd get, let me quickly do it here. You'd get positive 14.99, which the key thing here again is not that it's 14.99, but that it's positive, which means you're concave up, and that means you found a minimum. And so we just need to answer the question now. The question wanted to know the dimensions, and so we know that 16 is equal to x squared times y, so we could get y is equal to 16 divided by 2.34 squared. So y is 2.92, and so feet. So my dimensions would be 2.34 feet by 2.34 feet by 2.92 feet. Alright, so let's move on to another question here. Another question I had was from the section on Rolle's theorem. I don't remember which problem number this was, but it was verifying that Rolle's theorem applies on the sine of 2x on the interval from 0 to pi over 2. And then if it does apply, find all points C. So Rolle's theorem. Well, first off, you have to state that it's continuous. Well, a sine function is continuous. Well, it's continuous on that interval 0 to pi? Yeah, of course it is, because it's continuous on all real numbers. And then we also need to determine if the derivative is defined. Well, the derivative of the sine of 2x is 2 cosine of 2x, and this is defined for all r. So we are differentiable. And then we have to check to see if the endpoints are equal to each other. And so in this case, we have to check to see if the sine of 0, which is equal to 0, and then we have to see, well, what's the sine of 2 times pi over 2? Well, the sine of 2 times pi over 2 would be the sine of pi, which also equals 0. So Rolle's theorem applies. And Rolle's theorem basically gives us that we have to have some points where the derivative is actually equal to 0 in the interval, so we just find those now. So we already have my derivative, it's 2 cosine 2x, so I just need to know when 0 is equal to 2 cosine of 2x, or we need to know when 0 is equal to cosine of 2x. And remember, cosine of theta is equal to 0 for pi over 2 plus n times pi. So we would have 2x is equal to pi over 2 plus n times pi. So you get x is equal to pi over 4 plus n times pi over 2. And then we have to make sure we pick the ones that are in the interval. So remember, our interval here that we're looking at, the interval that we were given in the original problem was 0 to pi over 2. So I'm going to make a little table over here. Look at n and x. I always start with 0 and I kind of put it in the middle, because 0 is easy because that's pi over 4. Well, that's clearly in the interval. If I do 1, you would have pi over 4 plus pi over 2, which is 3 pi over 4, which that's not in the interval, so I don't have to do any more positives. And I should check the negative just to make sure. So this would be pi over 4 minus pi over 2, which is negative pi over 4, which is not in my interval either. So I don't have to check any more negative numbers. And so I only have one number, but the theorem says there's at least one, and the number in this case is pi over 4. We had another question from this section. And another question from this section dealt with the mean value theorem. And so I don't have the problem number written down, but it was 3 sine of 2x. And we're supposed to determine if the mean value theorem applies, and then if it does apply, determine all points C that satisfy what the mean value theorem states. Now remember, there's only two things to check here in the mean value theorem, so I'll say this is equal to f at x. Oh, I also have to write down the interval. The interval we're given is 0 to pi over 4. So we need again to determine if it's continuous. Well, just like in the previous problem we did, we know that f at x is continuous. On all r, all real numbers. So clearly it's continuous on 0 to pi over 4. And then we have to check to see if it's differentiable, but again, the easiest way to do that is just take the derivative, which would be 6 cosine of 2x. And so this is clearly defined. Oops, can't spell the word defined here. For all x, so f at x is differentiable. And you do need to write things like this on the exam, or you'll lose points on the problem. Okay, and then we have to say, well, now we know that mean value theorem applies, because there's only two things to check for mean value theorem. And then remember, what we need to do here is we're trying to find those points C, but what I always do first is find f at B minus f at A over B minus A. That's what I always like to find first. Okay, so then what do we do here? Well, we have 3 times the sine of 2 times pi over 4 would be my f at B, which would be 3 times the sine of pi over 2, which is just 3. Then you have 3 times the sine of 2 times 0, which would be 3 times 0, of course, which is just 0. So my f at B minus f at A over B minus A is equal to 3 minus 0 over pi over 4 minus 0. So this is going to be equal to 12 over pi. And then what we do here is we set my derivative, which we have f prime at x. Let me scroll back here, make sure I get f prime at x correctly. 6 cosine 2x and so then we're wanting to know, when is 12 over pi equal to 6 cosine of 2x. Now this is where you just have to use your calculator on some of this, because these numbers aren't going to be pretty. So you get here 2 over pi is equal to cosine of 2x. And I'll just go ahead and write some of this out here. Inverse cosine of 2 over pi, oops, not 2 pi, is equal to 2x. And then you just get that x is equal to the inverse cosine of 2 over pi divided by 2. And that's going to be the only one that we have, even though it is periodic. Because I'm on such a small interval, I'm not going to get any other ones. But I would just go ahead and compute that. I'm in the wrong mode. Make sure you're in radians. When you're doing these, I just was in degrees. And I get that this is approximately 0.440. Now I do have a few other questions, but I'm going to stop this video just so it's not too long.